Number 9, taken from the A-level past paper C2 January 2008, topic differentiation. Let us read the question. Figure 4 shows an open-topped water tank. So by an open water tank, topped water tank, it means that you don't have an area here, it's open. So you only have a base and the walls of the tank, which is made of metal sheet. The base of the tank is a rectangle, x meters by y meters. The height of the tank is x meters. The capacity of the tank is 100 meters cubed. Capacity, what they mean by it is the volume, 100 meters cubed. Remember that the volume of the cuboid is the area of the base, which is x times y, times the height, which is x, therefore it's x squared y. So that the area A m squared of the sheet metal used to make the tank is given by this. So in other words, we want to find the total surface area. So we start with finding the volume, and when we find the volume, it's going to be x squared times y equals to 100 meters cubed. We will see now that we're going to use it, because if you look at what they want us to reach with respect to the value of the area or the expression of the area, it doesn't contain y, so it only contains x, so it's area in terms of x. In order for us to find first the total area is equal to the area of the base, which is x times y, so this is the area of the base. Then we have these two rectangles that are the walls, and these two rectangles make 2x times y again, so it's 2x times y, plus we have the other two walls that form a square, or they form squares, so it is 2x squared. And remember that you don't have a top because the top is open. This is a water tank which is open. Therefore, rewriting A, or the area, the total surface area, it's 3xy plus 2x squared. Now we have a y here, and that we need to get rid of, and we can find the value of y here in terms of x. It's 100 over x cubed, so you replace it here like we did in this part here, and we found out that a is equal, or we reached what they want us to find. A is equal to 300 over x plus 2x squared. Part B, use calculus to find the value of x for which a is stationary. So when a is stationary, it means the derivative is 0, therefore you have to derive a. In order for you to derive a, you need to write a in the form that we can use it to derive. So a, we have here an x in the denominator, we need to write x in the numerator with an exponent. So a is written as 300 x to the minus 1 plus 2x squared, and then we derive it. So this is minus 300 x to the minus 2 plus 4x to the 1. Now in order for us to find x, the value of x, we need to place a prime equals 0. So when you place a prime equals 0, you have to solve for x. So I'm going to solve it here. So a prime equals to 4x minus 300 over x squared equal to 0. So 4x is equal to 300 over x squared. So 4x cubed equals to 300. Therefore, x cubed equals to 300 over 4, which is equal to 75. So x is equal to cube root of 75. Using your calculator, you're going to find that x is equal to 4.22. And it is in meters. C, prove that this value of x gives a minimum value for a. So in order to prove that this x, which we found, gives a minimum value for a, you have to take to find the second derivative. So you take the derivative and you derive it again. Deriving it, you will get this, and then you replace x. When you replace x, you're going to find that the value for a double prime is greater than 0. When it's greater than 0, it means you have a minimum value for a, for this particular value for x. Calculate the minimum area of sheet metal needed to make the tank. So you take the value of x and you replace it in a, which is this, and then you find the value of a, which is 107 meters squared, which is the minimum value of a metal sheet that you need to make this water tank.